Have you ever wondered where everything came from? How did the vast universe, filled with billions of galaxies, stars, and planets, come to be? The most widely accepted explanation is the Big Bang Theory. It's like a grand cosmic story that explains how our universe began. Imagine a time when there was no space, no time, and everything existed as a single point. Then, in a sudden burst of energy, the universe was born and everything began to expand. The Big Bang wasn't an explosion in the traditional sense, like a bomb going off. Instead, it was the rapid expansion of space itself. Imagine a tiny balloon suddenly inflating to an enormous size that's closer to what the Big Bang was like. This expansion continues to this day, though at a much slower pace. The Big Bang Theory is supported by a lot of scientific evidence, making it the leading explanation for the origin of our universe. It's a story that continues to fascinate scientists and stargazers alike. The Big Bang Theory is our best attempt to understand the grand cosmic drama that unfolded billions of years ago. It's a story that's still being written as scientists continue to make new discoveries and refine our understanding of the universe's earliest moments. In the beginning, there was no beginning as we understand it. Time, space, and matter were all compressed into an unimaginably small, hot, and dense point. This point, often called a singularity, was not located in any particular place. It was not surrounded by empty space. It was the universe itself, condensed into an infinitely small point. Imagine, if you will, all the matter and energy that make up the stars, planets, and galaxies we see today. Now imagine all of that squeezed into a space smaller than an atom. That's how dense the universe was at the moment of the Big Bang. This tiny seed of the cosmos contained within it the potential for everything we see around us today. The conditions in this early universe were extreme, beyond anything we can recreate in a laboratory. The laws of physics as we know them break down at such extreme temperatures and densities. Understanding the singularity and the very first moments after the Big Bang remains one of the biggest challenges in cosmology. Scientists are constantly working to develop new theories and models to explain this enigmatic beginning. Despite the challenges, the idea of the universe originating from a single, incredibly dense point is a captivating one. It's a stark reminder of the vastness and mystery of the cosmos. Then came the Big Bang, but not with a deafening roar. Instead, it was the beginning of an expansion, an unfolding of the universe itself. Space expanded rapidly, and with it, the energy and matter within it began to cool and spread out. This period of rapid expansion, known as cosmic inflation, lasted for only a fraction of a second. During this incredibly short time, the universe grew exponentially, increasing in size by an unimaginable factor. Imagine a grain of sand suddenly swelling to become larger than our entire galaxy. That's the scale of cosmic inflation. This rapid expansion stretched out the fabric of space-time, smoothing out any initial wrinkles and irregularities. This period of inflation is crucial for understanding the large-scale structure of the universe we see today. It explains why the universe appears relatively uniform in all directions, and why the cosmic microwave background radiation, a faint afterglow of the Big Bang, is so evenly distributed. While the universe's early growth spurt was dramatic, the expansion didn't stop there. It continues to this day, albeit at a much slower pace. Astronomers have observed that distant galaxies are moving away from us, and the farther away they are, the faster they seem to be receding. This observation provides further evidence that the universe is still expanding, just as the Big Bang Theory predicts. As the universe expanded and cooled, the energy that was initially present began to transform into matter. This wasn't the kind of matter we see around us today, like rocks, water, or air. Instead, it was a swirling soup of fundamental particles, the building blocks of everything in the universe. These particles included quarks, electrons, and other exotic particles that are rarely seen today. The early universe was a chaotic and energetic place with particles constantly colliding and interacting. Over time, as the universe continued to cool, these fundamental particles began to combine and form more familiar particles. Quarks came together to form protons and neutrons, the building blocks of atomic nuclei. Electrons, with their negative charge, were attracted to the positively charged protons, eventually forming atoms. These were the first atoms, mostly hydrogen and helium, the lightest and most abundant elements in the universe. The formation of atoms marked a crucial step in the evolution of the universe. It allowed light to travel freely for the first time, making the universe transparent. From this point onward, the universe continued to evolve, with gravity playing a key role in pulling together clumps of matter to form stars, galaxies, and eventually, planets like our own. We are all made of star stuff, forged in the heart of stars that formed billions of years after the Big Bang. Section 5. Echoes of the Big Bang. How do we know about the Big Bang if it happened billions of years ago? Amazingly, we can still detect faint echoes of this ancient event in the form of radiation. This radiation, known as the cosmic microwave background, or CMB, is like a baby picture of the universe. It's a faint glow of light that permeates all of space. This glow wasn't always visible. For hundreds of thousands of years after the Big Bang, the universe was so hot and dense that light couldn't travel freely. It was like a thick fog that scattered light in all directions. As the universe expanded and cooled, this fog finally lifted, and light was free to travel across the cosmos. The CMB we detect today is that first burst of light, stretched and cooled over billions of years as the universe expanded. It's like a message from the early universe carrying valuable information about its conditions shortly after the Big Bang. The CMB isn't perfectly uniform. It contains tiny fluctuations in temperature, representing minute variations in the density of the early universe. These fluctuations, though small, were crucial. They acted as seeds for the formation of all the large-scale structures we see in the universe today, from galaxies and galaxy clusters to vast cosmic voids. Section 6. Unveiling the Mysteries, a Historical Journey. The Big Bang Theory didn't just appear overnight, it's the culmination of decades of scientific discoveries and observations. In the early 20th century, astronomer Edwin Hubble made a groundbreaking discovery. He observed that distant galaxies were moving away from us, and the farther away they were, the faster they were receding. This observation, now known as Hubble's law, provided the first evidence that the universe was expanding. If the universe is expanding, it means that it must have been smaller and denser in the past. This realization paved the way for the Big Bang Theory. Another key piece of evidence came in 1964 when Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background radiation. They were using a large antenna to study radio waves from space when they detected a faint, persistent hum that seemed to come from all directions. This hum turned out to be the CMB, the afterglow of the Big Bang. The discovery of the CMB provided strong support for the Big Bang Theory, and Penzias and Wilson were awarded the Nobel Prize in Physics in 1978 for their groundbreaking work. The Big Bang Theory continues to be refined and expanded upon as scientists make new observations and develop new technologies. It's a testament to the power of scientific inquiry and our never-ending quest to understand the universe and our place in it. Section 7. Beyond the Big Bang, Exploring Other Ideas. While the Big Bang Theory is the most widely accepted explanation for the origin of the universe, it's not the only one. Scientists are always exploring alternative ideas and challenging existing theories. One such alternative is the idea of an oscillating universe. This theory suggests that our universe might be just one in an infinite series of expanding and contracting universes. Imagine a balloon that inflates, deflates, and then inflates again, repeating the cycle endlessly. Another intriguing idea is eternal inflation, which proposes that our universe is just one bubble in a much larger multiverse. In this scenario, inflation never completely stopped, and new universes are constantly being born from the vacuum of space. These alternative theories, while fascinating, lack the same level of observational evidence that supports the Big Bang Theory. However, they highlight the fact that our understanding of the universe is constantly evolving. Scientists are currently working on new telescopes and instruments that will peer deeper into space and time, potentially providing us with even more clues about the universe's earliest moments. The search for a complete and comprehensive understanding of our cosmic origins is far from over. Section 8. The Big Bang Theory, Our Cosmic Compass. The Big Bang Theory is more than just a scientific explanation for the origin of the universe. It's a profound idea that has revolutionized our understanding of our place in the cosmos. It tells us that we are all connected, that the atoms in our bodies were forged in the heart of stars that formed billions of years ago from the primordial soup of the Big Bang. It highlights the vastness of the universe and the incredible journey that matter and energy have taken to create the world we see around us. The Big Bang Theory has also driven scientific progress, inspiring new technologies and techniques to study the universe. From powerful telescopes that can peer billions of light years away to sophisticated computer simulations that model the early universe, the quest to understand the Big Bang has pushed the boundaries of human ingenuity. While the Big Bang Theory provides us with a framework for understanding the universe's origin, it also raises many questions that remain unanswered. What caused the Big Bang? What happened before the Big Bang? Are there other universes out there? These are just a few of the mysteries that continue to fascinate and challenge scientists. The Big Bang Theory is a testament to the power of human curiosity and our unwavering desire to explore the unknown. It's a story that began billions of years ago, and it's a story that continues to unfold today as we explore the cosmos and unravel the secrets of our universe.